Charles Law. The Charles Laws name honors the pioneer balloonist Jacques Charles, who in 1787 did experiments on how the volume of gases depended on temperature. Charles's law states that the volume of an ideal gas, at constant pressure, is directly proportional to the absolute temperature. This law applies to ideal gases held at a constant pressure, where only the volume and temperature are allowed to change. Charles's law is expressed as V1 over T1 equals V2 over T2, where V1 equals initial volume, T1 equals initial absolute temperature, V2 equals final volume, T2 equals final absolute temperature, measured in Kelvin, not degree C or degree F. Some applications of Charles' law. Helium balloon. On a chilly day, the balloon crumbles. However, if the balloon take to a warm room, it regains its shape. This happens because the temperature on a cold day is low, and, so, the volume decreases. And in a warm room, the temperature increases. With an increase in temperature, the volume also increases. Therefore, the balloon goes back to its original shape. Bakery. Yeast used in baking to make the bakery products fluffy. Yeast is responsible for releasing carbon dioxide bubbles. These carbon dioxide bubbles expand further with high temperature. The expansion of the carbon dioxide bubbles with an increase in temperature works as a leavening agent and cause the bakery products to become fluffy. Hot air balloon. When a gas is heated, it expands. As the expansion of the gas takes place, it becomes less dense and the balloon is lifted in the air. The warm is less dense than the cold air, which means that it is lighter than the cold air. Turkey timer. The pop-up turkey timer is placed inside the turkey. As the temperature increases and the turkey cooks, the gas inside the thermometer also expands. As soon as the timer pops, it indicates that the turkey has been cooked. Deodorant spray bottle. Under high temperatures, the air molecules inside the bottle will expand, which can lead to the bursting of the deodorant bottle. Dented ping-pong ball. When dented ping-pong ball float on hot water, the temperature of the air inside the ball also increases. This, in turn, leads to an increase in the volume of the gas. Therefore, the shape of the ball is restored. Tire. Driving increases the temperature of the tires, and, therefore, the air inside the tire warms and expands. However, in cold weather, the pressure of the tires is low. Basketball. A basketball on a cold winter night shrinks in size. However, the basketball gains its volume back when the environment is changed in a warm room. Pool float. After inflating a pool float and push it into the pool, it seems a bit underinflated. This is not because of any leak in the float. This happens because the temperature of the water in the pool is low, which reduces the volume of the air inside. Automotive engine. In spark ignition, gases from the very process of combustion are exposed to high temperature. Increase in temperature will lead to an increase in the volume of the gases. As this process continues, the force against the cylinder and piston head is increased, which causes rotation of the crankshaft. In diesel engines involving the process of compression ignition, the air is compressed under high temperature. Let's try to answer the following. A law stating that the volume of an ideal gas at constant pressure is directly proportional to the absolute temperature. The French scientist who made accurate observations on this is blank. B. Jacques Charles. Assuming that the pressure is held constant, what happens to the volume of a gas when the absolute temperature doubles? B. It is doubled. In a hot air balloon, the fuel used heats the air inside the balloon. Heating the air increases the speed of its gas particles in air, so they move faster and spread out. A hot air balloon is an application of blank. B. Charles' law. What temperature scale must all temperature measurements be converted to? A. Kelvin. Which of the following is an application of Charles' law? D. Rising of the dough when baked.